Can you use linear regression if you have categorical data? On first blush, that might just seem like a clear no to you. I mean, based on your experience with linear functions, they take real numbers in, they give real numbers out. But there are a few ways that people deal with categorical predictors when they want to try to use linear regression anyway. For example, suppose you're trying to predict somebody's salary. And one of the predictors you have is that person's highest degree. And you have these as your options. One thing people might try in this situation is assigning these values numerical values. And notice that these numerical values are encoding assumptions. So that's kind of risky maybe, but in this case the assumptions make sense because education levels are ordered. This person is less educated than this person, is less educated than this person, is less educated than this person. Obviously using educated in a specifically academic sense here. So having 0 be less than 1, be less than 2, be less than 3 makes perfect sense. What if instead of this, or in addition to this, you have degree type? And that's just for simplicity. Let's only look at 3 possible values. We know this is not true, and there are many degrees you could take. Um, at first blush, we could do the same thing that we did up here. But this is assigning order to these degrees. The fact that math is less than business, is less than psychology, says something. And it's not necessarily saying anything you want to say. Um, so another way that we deal with categorical data when it's not ordinal, when there's not any obvious ordering to the values, is called one-hot encoding. So at the moment, we have a single categorical variable that can take on 3 separate variables. One-hot encoding works by increasing the number of variables. From one variable, we go to 3 variables, and now we have a math variable. And this is binary. People can have a math degree or not. And we have a psychology variable. Again, it's binary, a business variable, I meant to say. People can have a business degree or not. And we can have a psychology variable. Same logic. Why am I talking about this now? Did I just forget to talk about it in the linear regression section? Well, yes, sort of, but also I'm talking about this now because it directly leads into our next bit of material. So here, we looked at what happens if the predictors in a linear model are categorical. And we've seen there are ways around it. Not necessarily perfect ways. These have limitations that we're not going to get into, but there are ways around it. What if the target variable is categorical? Well, of these ideas that we have for dealing with categorical data, one of them is obviously right out, and that's one-hot encoding. Because one-hot encoding replaces a variable with new variables. And obviously, if this is our target variable, we can't get rid of it. So that leaves us with this. And people will sometimes, I'm never quite sure why. You will occasionally see people try to deal with categorical target variables in this way. But I mean, what we have here is a fundamental mismatch because I mean, the output is always going to be numerical. I mean, more to the point, the output is always going to be a real number. So if your target variable here is degree level, well, the output I mean, isn't going to be 0, 1, 2, or 3. You're going to get outputs like negative 0 point, like this. And then I guess you can try to patch things up. You can say, well, of the possible values, this is closest to 0, so maybe we assign this to none. But but there are other issues here, and wouldn't it be nicer if instead of trying to jury rig this inappropriate method, we had something that was actually designed to work with categorical variables? Well, good news, because we have a tool that is designed to do what we are trying to do here. And it is called logistic regression. Now, logistic regression, just like linear regression, gives you real numbers, but the output of logistic regression is always going to be between 0 and 1, and the output of the logistic regression is going to be interpreted as a probability. The probability that looking at everything we know about a person, the probability that they do not have a degree, the probability that they have a BA, the probability that they have a master's, the probability that they have a PhD. And then we take the highest probability. If we do logistic regression, and we find the probability that they don't have a degree to be zero point 0.1, the probability that they have a BA to be zero point 0.7, the probability that they have an MA to be 0.15, the probability that they have a PhD to be 0.05. Well, we look at these numbers and we say, well, that's the highest number. This person probably has a bachelor's degree. And I'm sort of curtailing this section just because, well, it's an 8-week class. We've already covered a big section this week, but we'll talk a little more about this in coming videos and coming Canvas sections.